welcome everybody. Thanks for joining. Thanks for attending this developer workshop. So the topic of today is like our Conjure.finance developer workshop. So first off, who we are. So basically, we are currently a core team of 2 people building Conjure.finance, which is basically a toolbox which lets any user create any synthetic assets they can imagine. Basically, currently we are on Ethereum mainnet, also of course on the testnets on Polygon, and we are also in talks with other chains to deploy there. So basically, what is on today's agenda? First off, we'll give a quick overview what basically our product is, what our protocol is all about. Also, I want to give like an overview over our Open Oracle framework, which can bring a lot of new data feeds on-chain. We'll show you how the development process, how our development setup, and which tools we are using to develop our contracts, to test them, and also to get them into production is. Also, I want to tell you how to set up an Oracle contract from scratch with the Open Oracle framework, getting any API data you can imagine and creating a data feed out of it, and actually also running the node. And after we have accomplished all of this, we'll give a quick intro to our Conjure.finance protocol, and then we will create a new synthetic asset using the previously defined Oracle feed. And at the end of the session, I also will have a dedicated question and answer block. But you know, since I heard this meetup is like very beginner friendly, you can always raise your hand and ask me any question at any time. So I will hope to cover them all. And basically, yeah. So of course, I want to. Oh, we have a chat. Oh, sorry. So basically, I want to cover them all, and so nobody ever gets lost here in the process. All right. So basically, one short outlook what the Conjure.finance Open Oracle framework is in general. So basically, as I said, Conjure lets like any user create any synthetic assets they can imagine on Ethereum or basically on any other chain. So basically, we are just a toolbox, which is like permissionless and open source, basically. And you can basically provide any Oracle data feeds you can imagine. So for example, you can create or use Oracle feeds based from Chainlink, Dia data, Bench protocol. You can even provide custom Oracle feeds. You can even use Uniswap or other text built in Oracle. So basically, you have like a whole bunch of different Oracle feeds you can choose from, of course, depending on the network you're on. But basically, that's why we rolled out to Ethereum first, because there is like the most out of any other chains in terms of data picking and data sources. Yeah. But you know, as the time came, we realized it's very hard, you know, to get new synthetic asset prices. So basically, price feeds on chain, for example, on Chainlink, they provide very good service. But you know, if you want like to have a new API, for example, if you want to have like banana prices or any other commodity prices which are not really on chain yet, you have like to make a request to a node provider on Chainlink, and yeah, it's quite a long and hard process to get listed there. And that's why we came up with our own framework, this Open Oracle framework, where I also want to show you on the first part of the presentation on the workshop today how you can actually use this framework to bring your own data feeds on chain. This can be on Polygon network, this can be on I don't know, on any testnet of Ethereum, and also of course on the Ethereum mainnet. But the idea of the Open Oracle framework is like that it should be a framework which is permissionless, and you can do like Oracle deployments and robust and flexible on-chain price feeds. That's what you get in the end. So oracles here are simply multi-party median value feeds, but you can even implement your own price logic to a dedicated proxy owner, which itself is like their own price logic. And the median value model takes the value of n signers and uses the median value submitted and makes sure that the other signers of the threshold, that the threshold has been met and returns the value. So basically, on Polygon, for example, we're running like our main price feeds, which we offered for as like a threshold of 4, and with a setup of 3 out of 4. So basically, if 3 signers can sign the oracle, then it's good to go, and the price is written into the epoch timestamp which we are looking. I want to move on to the part where we can actually mint our own Oracle framework, because like in the description of the event, we wanted to show you or said that you can create your own contract within like 5 minutes and they're ready, or 10 minutes and they're ready to go and actually sign the values. So let's look at it. So first off, I will go here to Google Chrome, and I already have, so basically I'm showing you this here on the Polygon network. Basically I just set up two new accounts actually for this workshop, where I have some Matic on it to pay the actual gas costs. And basically this contract here is this Open Oracle factory. Yeah. So basically that's one-to-one the code we have seen before. Yeah. Also, this OOF implementation contract, which also is deployed here, is like the implementation contract where we have it like here. Because the first time, if you use this clone pattern in the deploy contract, basically on Polygon, it's not a problem, but it's like very gas intensive. But after that, if you use the clone pattern, it's pretty much no problem and brings the costs down tremendously. So basically, why we have here the this constructor thing where we have like the address set to where is it? Yeah, where we have the effect we've set it to 1, because we don't want anyone to alter this contract at all, because it's used for cloning, right? But if we go back here, for example, to the to the actual contract, you can we also, so basically we have this address is also available on the Ethereum network. So basically it's one-to-one the same code, 100%, and so anyone can of course create their own Oracle price feeds and oracles on Ethereum too. But in this demo, I want to show you how we can actually mint a new Oracle here on the Polygon network. So first, let me connect to the network here, or to Polygon Scan. Let me just check if it's the right account. Seems good. Then I just go over here to this OOF mint function. So basically, I want to start out by just using one signer here, which is actually the address, which is the address which I'm using here. Then I want to do a threshold 1 of 1. Of course, this is just for demo purposes. Of course, we can in a production environment, 1 of 1 is never good, because it's centralized, and 1 of 1 is just a real big point of failure, So for example, on Polygon, we're using 3 out of 4. On the Ethereum, we have like 2 out of 3, but the more the better. For the payout address, I just paste the address in here. I could also use the 0 address, but 1 of 1, the equal switch, the equal split would be 100% to this address, and the subscription price I will set to 0, because in this demo I will make all feeds available for this for all addresses. Yeah. Then I click here on right, then the MetaMask confirmation pops up. I will just increase the price here a bit because lately the Polygon network, took like forever for me. We'll just confirm this. And while this is confirming, you can actually see it here. Hope it goes through fast. Maybe it's already mined. Yeah, perfect. It's already mined. And then we can look here in the events log and see, okay, 17 seconds ago, a new Open Oracle framework has been minted. So we can actually go to the address here. Yeah, basically we have no transactions on it, that's fine. And if we go to the contract code here, basically it's 100% the code of the implementation, right? But this time, because we use the clone pattern, the value of the contract is not set to 0. Yeah. Where's this constructor of the factory contract? Because we actually already called this initialize function, and the contract is now good to go. Because if I go to read contract, here, okay, we say feed length is 0. That's because we didn't define any Oracle feed before, right? That's what we are doing like in a second. Yeah. Payout address is set to the signer address. I already said signer length is 1 because I only defined one sign. And if I just look which value we have in the signer array, it's just 1 because the signer we just entered was just this one address. So basically we are just good to go here. Okay, so that's just basically setting up the Oracle itself. The next part is the node here. So basically, we also have it available in our GitHub. You can just git pull this. It's called OOF nodes. That's the GitHub directory we have, and are basically good to go. So the only thing you have to alter is this .env file. It looks like the following. Basically, you just have to provide the private key of this address we are using. Then we have to define the RPC. This will actually differ because if we're on Polygon mainnet, we have a different RPC than on Ethereum or I don't know, Binance Smart Chain, whatever. The OOF address we are using is basically this address here, yeah, because that's the new address we are using as the Open Oracle framework, yeah. And then as of the time being, we want to import our actual price feeds. So at the moment, and this is still in beta, I have to just look how I can move this thing here. Yeah, perfect. So basically right now, the feeds here are sitting in a Google spreadsheet. It's just MVP, and we are moving all the feeds later maybe to an Airtable or to a relational database or whatever. But just for the time being, it's just a really convenient way to like play around and build out this whole stuff. So basically what we are doing here, for example, for the current time being on Polygon, we have like these 53 feeds available. I think it's like 54 because we have like the 0 also. And basically we are accepting this format at the moment. So for example, we have the feed name, the feed ID, it's the API endpoint. That's the real magic here, because if we are just opening this API, it will return something like this: Ethereum, US dollar, and then the price, right? Then we define the update frequency, which is now set to every 1 hour. The decimals are not the return decimals from the actual value we are getting here, but the decimals is we basically we are just multiplying the value which comes out by the power of this decimals, and then get like more room for like further integrations. then also we have like this little parser column, which just routes us from this JSON response directly down to the price. For example, here we have like Ethereum USD, and in this format we also specify Ethereum USD, and then we know after we go down this path here, then we see the price, right? And then we also obviously have a description here. So for example, if you take like another example, for example, I think I have one open. Let me check. I think it's like, this is like the banana price feed, which is here, for example. If we go here, just missed it. For example, if we want to get the price here, for example, then we have to go like the root dataset, data, then obviously we have here an array, and then it takes the first one. So it will be looking somewhere like, yeah, dataset data 01, because obviously it's like the first and then the second part of the array, because here it's the second one, but in this it's the first one, but in the first one we take the second value. So we don't want the date where it was updated, but we want the actual value, right? And for this workshop, I actually prepared here like a new column, which is like called workshop here. And I just wanted to go with like a few feeds, like 7 feeds in advance in the sample, and bring them actually, yeah, actually on chain, on Polygon, on our Oracle framework. So basically, I just updated the .env file with the new Oracle address. Like, how can I get rid of this? Yeah. So basically, I just pasted in this address as the new Oracle address. And the first thing we have to do is we have to run to this setup feeds. Yeah, this setup feeds script. So basically, this script, it's also publicly available at our GitHub, and it will just go over the information here, and then insert the feeds. Basically, there's 7 feeds into the contract, so we are ready to sign them actually. So basically, I will just start this script here. If all went okay, so it's okay. 7 feeds were found 0 in the contract, and now it says it's creating the feeds. So basically, that just depends like on the speed of, or the current speed of the network. We can actually go on the, okay, it's already created. You can check this directly on the contract. 1 second. So here on the contract, on transactions, we should now see, okay, we had 17 seconds ago, the creation, where we had like the create new feeds. And if we go into the contract and check, for example, the get feed list here, let's check it. 1, 2, 3. Yeah, there we go. Then we can see the first feed is the Ethereum USD feed, the BTC USD feed, and the Ethereum BTC. So basically, it's just it's just 101 how we gotten into here, right? Basically, here would be the value for the last price, and here would be the value of the last timestamp when the last price was written. Obviously, we have 0 here because we just created the feed, and now after the feeds are created, actually we are ready to go run our node, so that the node signers can actually update the feed prices from the API, pull it from the API, and actually insert it into the feed. Let's do this really quick. So basically, this setup feed script is just for providing the feed information. Obviously, if we create another feed here, for example, we update it here and run the script again, it would be that we just have one additional insert. So you can use this script for additional feeds also. Yeah. So basically, that's the main script here. That's the OOF node script. It's a bit more complex, but actually what it does. So actually, if you're a feed signer, you want to take the script and let it run. I don't know. On an environment which is always up, for example, AWS or Azure, or I don't know, Google Cloud, or you have like a dedicated PC or computer where you have where it can basically run in the background to make sure it's always executable and is always connected to the internet. Yeah. So basically, what it does it goes to this Google Sheet here again. To this special lash here, and extracts all the data from here. Especially the important thing is here, it extracts the API endpoint. Yeah. Basically, it extracts all the data, and then basically it runs every 1 hour periodically until the script is stopped. And basically, what it does is it goes through all these APIs, pulls the newest information, so the newest data, because of the window here again. Because of the parser here, we know it knows where the value is actually stored, and then actually the interesting part is after all those informations are gathered, the interesting part is here where basically a submit feed function of the actual Oracle contract is called. Basically, it's called with the feed IDs and the values. So for example, if we just wanted to run this script now, the parsing would be the following. It would submit all the feed IDs from 0, 1, 2, 3, 4, 5, 6. And then it will, in the second array, insert all the values which is gotten for the actual prices, for example. I don't know the actual price right now. I think it should be anything around 3,000 for Ethereum, BTC, and yeah, it just goes down here all the data and parses and actually submits direct on chain to the contract. So basically, on Polygon, we should not have any problem because on Ethereum, obviously the gas prices vary a lot and can be a lot, and the times to actually confirm a transaction can go up like to 10 minutes if the gas price spikes. And we actually have also code provided that after 5 minutes and a transaction is still not confirmed, we will resend it with the same nonce, which basically replaces the actual transaction, increase the gas price a bit in the hope that this transaction goes through then. And we do the cycle all over again until, the feed is then actually submitted. So obviously should be all confirmed within 1 hour. That's better then. So basically, we can now just run the script and see if our feeds get signed. So basically, set up feeds. That's not correct. I want the OOF node. So basically, it's checking here the APIs. You can see the values it's getting. And afterwards, it says, okay, the gas price in the actual is actually 1.01 weight. And it says, okay, it submitted the feeds here, and you actually also get the transaction hash. So if we let this script run for an additional 5 minutes, it should be checking if the transaction is still open. But I think since we're on the Polygon network, we should have this problem, and we also already can see in the contract that our feeds are signed. So basically here, okay, that's the actual signing transaction. And if I go to the contract here and we check if we have a new value for our Ethereum price, yeah, we have something. Okay, it's just for integration purposes. We are turning also the decimals, but that's the Unix timestamp of the sign of the last price finding action. And here we have the actual current Ethereum price, which was returned from, in this case, it's the CoinGecko API. And we have $3,017.34 roundabout. Yeah. All right. So basically, that's all we need to do to get like the get our feed signed. So basically, that's all about with the Open Oracle framework. So basically, with these 3 simple steps. So first is to mint like a new Oracle, like we did before on the Polygon network, and like got this completely custom contract for our purpose. And the second one was we actually ran the setup node script, setup feed script, sorry, to get like from our Google Sheet or from our database the new feeds and APIs we want to sign. And the third one is actually the setup feeds node script, which runs in continuation forever and actually signs the feeds. So basically, in this demo, we just had one signer. So one signing of one feed will always push the newest value. But for example, if we had like 2 signers and we have a threshold 2 of 2, then the price will be stored internally until 2 of 2 signers have signed the value or the feed within this 1 hour or whatever the feed duration is, time window, and then pushes the value. So for example, if you had 2 of 2 and just ran this script now, we wouldn't have a value at all until the second signer came in and also signed the value. So I hope that makes sense. So basically, that's it with our Open Oracle framework and how we can get like a feed deploy, a whole Oracle and feed deployed within like a few minutes. And yeah, with our ready to use scripts here. And now I think, so are there any questions until now? Because if not, I will continue to integrate this actual data feed or one of the data feeds in our Conjure framework. So make a synthetic asset out of it so that all things come together.